Hello. So today we'll be going over Gorilla. So Gorilla is a new large language model. It is a Llama-based LLM fine-tuned on a dataset of API calls. Here we can see the abstract and the introduction. Uh, and let's go over one example of the dataset that it's been trained on. So the dataset is fully available on Hugging Face. You can download it. I think it is somewhere here. Yeah, you can download it from here, Gorilla-LLM API Bench. And here we can see one example of the dataset. So it has the code, which is the instruction, right? An API implementation that takes customer reviews. You're free, feel free to pause and read through it. So it has an instruction and an output and the code. So there are other elements of also of the data, which are basically for you to tell that what the API is doing, what is the API provider, and what is the data that is being processed. All right. So reading through the paper, the introduction and the abstract just goes over how this can be a transformative change in the LLM landscape and how Gorilla is better than GPT-4 and Claude. Uh, at the time of writing the paper, I think Claude 2 was not out, so it would be interesting to see how it compares to Claude 2. But we should take it with a pinch of salt as to how better Gorilla is, and we'll go through that later. Uh, and as you can see here, it goes over some examples of GPT-4. GPT-4 says it hallucinates, Claude takes the wrong library, and Gorilla does everything better. And we can see here with some zero-shot inference with some retrievers, we can see that Gorilla outperforms all of them all the time. But we'll again see that this is actually not the case as always. So but the zero shot model does look like it's much better than all the other language models mentioned here. So the model is actually trained on Torch Hub, TensorHub, and Hugging Face, but only the top 20 models of data. For each API call, they take 10 synthetic prompts that were generated using self-instruct. They actually use GPT-4 to generate synthetic instruction data. So in a way, they use the stones to destroy the thorns, destroy the stones, as Thanos would say. Uh, as you can see here, it says that we then fine-tune Gorilla, a Llama 7 billion based model with document retrieval using our dataset. Uh, you can read through this paper. Paper is actually very good. I'm going over the major parts of the paper. Here there's just related works like what is large language models, what is the tool usage, and uh, how can one use for LLM for program synthesis. Uh, the major chunk of the paper is the methodology. We have gone over the data set collection, which is that they use Hugging Face Hub, PyTorch Hub, and TensorFlow Hub models and their API invocation. Uh, how they in this image we will go through it. So the first part of this image is how they have trained it. They take the data set from here, they pass it to JSON, self instruct in context examples, and then the Gorilla model is fine tuned. How to use it? There are two ways that you can use it. You can use it with an information retriever. Information retriever is like a Llama index, which you can actually call and give more context to the large language model while you are inferencing it. Or you can just use it as zero shot inference, which does not go through the instruction, and then you can use it and execute the results. Um, and how they actually evaluate the model is something known as AST, subtree method. So here we go with the AST subtree methods here. So this is the output of the Gorilla model. Torch, Hub, Load, PyTorch driven DenseNet 121, retain is true. Now they have a tree over here of possibly all the combinations that could happen. And then they match whether this tree can be made a subtree of this overall larger tree. And if that is the case, they say that the output is correct. Otherwise, they say the output is wrong. And this is the way that they have evaluated their model as well as they have evaluated the output of GPT 3.5, GPT 4, and Claude models as well. So in the evaluation, if we come here and see, we see here with the accuracy, they go over the accuracy. We'll see that with retrievers, the accuracy for Llama is actually very bad. Llama, we all know, do not does well with code or writing any kind of code. It is mostly natural language inferencing. But you can see with retrievers, with GPT retriever, uh, the GPT 3.5, the GPT 4, the Claude, and the Gorilla, they don't have a lot of difference in accuracy. Yes, the Gorilla edges out very marginally over Claude and GPT 3.5, but it is not the best. Here also we see with Hugging Face and GPT Retriever, it's edges out just slightly. And actually on TensorFlow Hub, it is actually performing poorer compared to GPT 3.5. Whereas it is only when you use zero shot, which is you don't use any retriever, that the Gorilla model actually outperforms all the other models. As you can see on Torch Hub, it's the best. On Hugging Face, it performs better than any other because Hugging Face has a lot of models, so you don't know which model to choose. And for TensorFlow Hub also it outperforms all of them. But if you once you add any kind of retriever, like BM25, GPT Index, or Oracle, the difference is not that large. Actually, in some cases, you'll see that Gorilla, like in this case on TensorFlow Hub, Gorilla is actually not the best. It's GPT 3.5. So the Gorilla is a very good model. Like there's no doubt about it. But the uh, assertions that the authors make in this paper are not entirely true. Only when you're not using a retriever, then Gorilla is the best model to use. All right, once we have gone through the paper, let's go through a working example. The folks at Gorilla have also given us a notebook which you can play around with. And so this is just the code bit how you can call the API. It is already hosted somewhere. The model is hosted, so you don't have to call it. You don't need any API keys. You don't need any open AI API. So as you can see, it's empty. You don't have to pass it. We also installed some libraries like transformers, tokenizer, and sentence piece to check whether the output that they give is correct, and like they uh, claim that this is an API focused large language model. So the prompt is I would like to translate I feel very good today from English to Chinese, and we get the response. Uh, and we have already written their response. So this is the response that they give back. Hopefully, they give the same response back. As you can see, the domain is natural language processing translation. The API call is translation pipeline, and the API provider is Hugging Face. So it gives you all the context which is required, and they give it a nice explainer as well. And then they give you the code within these code token symbol. So this is the code. We just copy the code, we paste it here, and we check whether this works or not. To make sure that this works, you have to have a GPU instance. On CPU instance, it was giving me some sort of error. And we see, yes, we get the response. And if we use Google Translate, yes, it goes to I feel good today. So it seems to work, and this is a very good language model to write API code for you. If you don't know Hugging Face or Torch Hub or TensorFlow Hub, then this is an excellent language model to start off with. All right. Thanks for watching. Do like and subscribe, and let me know in the comments if you'd like me to cover any other topic.